Hi and welcome back to a new video. We recently reviewed the 9850X 3D, and in that video I also said that I originally wanted to delete the CPU already in the launch video, but I didn't find the time to do so. That's what I want to do today. I don't expect any kind of surprises because physically 9800X 3D and 9850X 3D should be identical, but you never know with AMD. They sometimes changed the glue and those kind of things. And I also want to find out if the CPU might be a little bit better when it comes to overclocking, because essentially the 9850X 3D should be a binned 9800X 3D, so maybe there is a slightly better margin. And also it's just been a while that I delivered a CPU. With a passion for IT and strong technical expertise, Hetzner delivers innovative solutions for demanding requirements worldwide. Operating its own state-of-the-art data centers in Falkenstein, Nuremberg and Helsinki, as well as cloud operations in the United States and Singapore, efficiency is always a top priority. The Hetzner Server Auction offers both standardized systems and individually configured servers that have already been in use, with no minimum contract period and zero setup fees. This allows hardware resources to be reused efficiently, extremely cost-effective and environmentally friendly at the same time. And now with the new code DEBAUER20, you will receive 20 euros off all Hetzner products. For all information, check the link in the video description. But before we start with the delidding straight away, I want to jump over to this system and get some baseline numbers for the temperature. The test setup consists of the ASUS X870E Hero BTF motherboard. We have obviously the 9850X 3D, which is currently being cooled by our Micro Pro water block. So that's a non-direct die water block, not yet released, but soon. And this is then cooled by the Mora, and also obviously RTX 5090. I overclocked the CPU manually with 5.4 GHz across all of the cores, and the core voltage is about 1.27 volt. I already passed 10 minutes of Cinebench R23 just to see what kind of temperature we can expect. And the first run, the max temperature was about 90.2 degrees Celsius, and the CPU package power draw is about 170 to 175 watts. On average, however, we can more see temperatures of about 72 to about 85 degrees Celsius under load. Back when we tested the 9800X 3D and Delidding, I was using roughly the same voltage, about 1.27 to 1.28. It didn't scale further with voltage even after Delidding, but that's still why I aimed for the same kind of voltage, so we have at least somewhat of a comparison. And going higher wouldn't really work non-Delidded, because you could see it already peaked at about 90 degrees Celsius, so going higher wouldn't really make a lot of sense without delidding. Now delidding, there is something I wanted to try for a long time, but I just never had a chance to do so. At some point I decided to heat up the delidder and the CPU inside to about 60 degrees Celsius because I wanted to test if it makes delidding easier. But at that stage it turned out that it actually is more difficult. I think the indium just becomes more soft when it's hotter, and thus I think it just took longer, so I had to move it more than 100 times to release the IHS. So heating up the CPU didn't really make sense, at least if you stay below the melting point of the indium. And now I thought, what about the opposite direction? I want to place the delidder and the CPU into the freezer at maybe like minus 10 degrees Celsius. It's not a huge difference to the room temperature, but maybe it helps. It should make the indium a little bit harder, maybe a bit more brittle, more affected by metal fatigue. That is essentially what we're using in this delidder. And maybe it helps, maybe it doesn't help. But I always in the past thought that there is maybe also a risk involved if you do this kind of method, going down in temperature, because also other materials will become more brittle or like more affected, more prone to fail with metal fatigue. For example, the solder that is holding the chip to the PCB. That's why I was usually reluctant to try it, but at some point you just have to try it. So that's what I want to do as well today. And here we have our CPU. One correction I have to make. I think I said I put Duronaut between the CPU and the block, but it was actually Cryonaut Extreme, as you can see also by the color. And now we put the CPU into the delidder. Just pay attention to the triangle, to the orientation. And then we can put it into the freezer. Now, half an hour later, I'm really happy that we have a kitchen at Grizzly. It's not as cold as I expected, but I will try it anyway. We're still at about 0 degrees Celsius. Usually I also wouldn't wear gloves for delidding, but this way it doesn't heat up as quickly. Moved it 2 times, I could feel the glue coming loose, so that's great. And now I will just simply move to the drill to speed things up. It's now loose. As you can see, I can move it by hand. And I'm under the impression that this was much quicker than what I had usually. When I just tried to remove it, it felt a bit sticky, kind of weird. So I had to move it a little bit to the side to release it. Never pull it up straight. That can definitely kill your CPU instantly. So always move it to the side. But yeah, worked out great from first look. Kind of as expected, no surprises. It looks exactly like any other 9800X 3D that I previously delidded. Now I just have to remove the glue and also the indium solder. I'm not quite sure on the conclusion of cooling the CPU down prior to delidding. It was definitely better than heating it up. At least if you just go to plus 60, plus 70 degrees Celsius, it took a lot longer than this. So cooling it down seemed to help, but I also wasn't super cold, right? It was like 1-2 degrees Celsius. But maybe next time I have to go even colder. Maybe I can order some dry ice and do like minus 50 degrees Celsius for once and just try it. The opposite direction obviously also works. You can go to like plus 170 degrees Celsius and melt all the indium instantly. Do one movement, take it out, but then you have to be careful, like with heat, not to burn yourself and also not to heat up the CPU too much, not to damage it. So yeah, but not sure yet on the conclusion how much it helps to cool it down, but it seems to help at least subjectively. I removed the majority of the indium mechanically, and now I will add a little bit of liquid metal to kind of remove the rest and leave it here for a couple of minutes. CPU is pretty much cleaned. Usually I now use some thermal paste and polish the remaining parts of the top layer. And what I also noticed a couple of weeks ago when I was doing a different investigation is that this top surface and those top layers, they are super complex. It's not only like right now we can see some remains of indium and underneath you may be able to spot some gold, but there's also, for example, titanium and nickel. So there's a very complex amount of layers that is the top coating of those kind of CPUs. And that is definitely something we want to investigate in a further video. For our short test today, this should be sufficient dose. I will just add some liquid metal and put it back into the system. We will cool it with the Micro Direct Eye Pro. I also applied liquid metal as usual on the bottom surface. Now, before we attach everything else, quick check if it's arrived, if everything is okay. I think it should be fine. I will attach the water cooling loop. Looks all great first sight, also temperature in BIOS. I will reapply the settings and go to Windows. All looks alright, settings are reapplied and also idle temperature looks okay, so we can start running Cinebench. Previously we compared 10 minutes, so we will definitely rerun that, but just first sight, it looks like something between 10 and 15 degrees Celsius, kind of as expected. Mount is good, so we can start the 10-minute test. The 10 minutes are almost over and we can see a peak of 77.4 degrees Celsius, which is exactly 13 degrees Celsius lower than the previous peak. And still we're seeing about, I would say, 15 degrees Celsius lower temperature than previously if you just look at how the cores are reacting. So that is exactly in line with all the other Ryzen CPUs that we delivered so far. Now I still want to test the overclocking capability of this sample and compare it to my 9800X 3D, which was able to run 5.6 at around the same voltage. But it's also kind of difficult to do this kind of comparison. I pointed this out multiple times, that if you compare two samples, like two individual CPUs, it doesn't mean a lot, because you're comparing those CPUs. It doesn't mean anything about the entire series. You would have to take a much bigger sample size, for example, 100 CPUs of the 9800 and 100 samples of the 9850X 3D, which I obviously don't have, but we just test what we have here, right? And we are starting a bit more relaxed with 5.5 gigahertz. I would definitely expect that the 9850X 3D should be able to handle this. Looks great. You can see 5.5, and also the temperature was good. Same as the score, so we can keep increasing. We will just increase 5.6. And now I'm curious because it's the same as my 9800X 3D. Well, it instantly froze. We will do one more try though with 25 megahertz less, so 5575 megahertz. Well, this also instantly froze. I even tried it again with a higher core voltage, went up by 30 millivolts to 1.30, which is a rather high core voltage, but it's fine for just testing. But even this was not enough for me to pass 5575 megahertz, which at least for my two samples means that my 9800X 3D is actually better. But that doesn't mean much because, as I said before, we are comparing two individual samples and that doesn't really mean much. And I also know from other overclocking results that my 9800X 3D was a rather good sample. But it just confirms that if you have a 9800X 3D, you definitely should not upgrade to a 50. It absolutely makes no sense. If you're upgrading from an older platform, you can do it because the price difference is not too much, that's fine. When it comes to the lidding, it's the same kind of temperature gain that you can expect, about 13-15 degrees Celsius, depends on your CPU, but that's roughly the temperature range. And also, if you're looking for a Delidded CPU with warranty, we again offer those at Thermal Grizzly shop, Delidded, pre-Delidded with warranty, and they are also available in the shop now. You can find the link to those CPUs in the description down below. I hope you enjoyed this video. See you next time. Bye bye.